Alright, so today we're gonna solve for homework 9, number 7. Step 1 is gonna be to solve for the homogeneous version. So we're gonna say y double prime minus 2y prime minus 3y is equal to 0. We're gonna do our characteristic equation and plug in the m's. So we have m squared 2m minus 3 is equal to 0. By doing this, we know our f of d is going to be equal to d squared minus 2d minus 3. We'll come back to that later. We can factor this out. It'll be m plus 1 and m minus 3. So our m values are going to be 3 and negative 1, which tells us that our fundamental solution homogeneous is e to the 3x and e to the negative x, which gives us our yc is equal to c1 e of 3x plus c2 e to the negative x. Step 2 is going to be to solve for the non-homogeneous version. Y double prime minus 2y prime minus 3y is equal to 2 e to the x minus 10 sine of x. The annihilator of the right-hand side of the problem is going to be d minus 1, which is from this e to the x, multiplied by d squared plus 1 from this 10 sine of x. We can use this now. We'll say this is equal to g of d, and we can use this to solve for our f of d times g of d, which is going to be equal to our d squared minus 2d minus 3 times d minus 1 times d squared plus 1. We can plug in our m's to make it easier to look at. And factor. So from this we can get our fundamental solution non-homogeneous, which is going to be equal to e to the negative x, e to the x, e to the 3x, cosine of x, and sine of x. We can use this to subtract our fundamental solution non-homogeneous by our fundamental solution homogeneous, which is e to the negative x, e to the x, e to the 3x, cosine of x, and sine of x, minus e to the 3x, e to the negative x. So these all will cancel out. We're left with e to the x, cosine of x, and sine of x. Now we're going to solve for our yp. You can see we'll have three variables. So we have alpha e to the x plus beta cosine of x plus gamma sine of x. So now we're going to solve for our yp prime and our yp double prime. Our yp prime is alpha e to the x minus beta cosine of x sine of x plus gamma cosine of x. Our yp double prime is alpha e to the x minus beta cosine of x minus gamma sine of x. So I'm going to flip over to the other side. And now we also have this written as alpha e to the x minus beta cosine of x minus gamma sine of x. So we can still see this. Minus, this one is our yp double prime. This part is our y prime times 2. So we're going to do alpha e to the x plus 2 beta sine x minus 2 gamma cosine of x. Just so you know where these are coming from. And this last one is our 3 times y. These are all yp's. So this is going to be minus 3 alpha e to the x minus 3 beta cosine of x minus 3 gamma sine of x. So now we can group these, and we have negative 4 alpha e to the x, because we have 1, negative 2, and negative 3, plus, we have negative 4 beta minus 2 gamma cosine of x, because we have cosine of x is here. And then we have plus negative 4 gamma plus 2 beta sine of x from our 2 sine of x here. This is all equal to our right hand side, which was 2e to the x minus 10 sine of x. So we can see that we have some common factors here and here. So this is going to be negative 4 alpha is equal to 2. So we can say negative 4 beta minus 2 gamma is equal to 0. And negative 4 gamma plus 2 beta is equal to negative 10. This gives us 2 gamma is equal to 4 beta, which tells us that gamma is equal to negative 2 beta. You can also see a similarity with this one and this 10. That's what it will equal, which is what we have here. So now we can replug. We have negative 4 times 2 beta plus 2 beta is equal to negative 10, which is from this formula right here. This is then equal to 10 beta is equal to 10, which tells us that our beta is negative 1. Therefore, our gamma is going to be negative 2 times negative 1, which is going to be positive 2. Now that we've solved for those, we can replug that, our yp. So now we have negative 1/2 e to the x minus cosine of x plus 2 sine of x. Now that we have that, we can do our general solution, which is